Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so if you see a screen here now, we are at the last final topic of this semester for semester 2, and the last final topic to end of your session studying in matriculation. Okay, so specifically in KMPP. So I do hope that all of you satisfied. Okay, even though all my videos might not make you satisfying you, okay, but then I do hope that all my effort preparing all these videos help you to complete the notes, try to understand the content of the topic, and helping you to continue with the tutorial and past year questions. So without wasting so much time, so let's continue our journey here now. Okay, so we look into the binomial distribution, where we stated at a b in bracket of n and p, where n is a number of trial, okay, and p is the probability of success. And we're going to find the mean and variance and use the binomial distribution to solve the related problems. Okay, so we look at the Bernoulli trials. There are two possible outcomes, only two. Okay, so it's either success or failure. Example, the head or tail, pass or fail, defective or non-defective, so on. Okay, for example, head or tail. So when we toss a coin, okay, I think that all of you know what this coin is. Okay, so just imagine that the face of this coin is it shows that we call the value of the coin, which is 50 cents. So we specify that we call this as a head and this part as a tail. Okay, so then the Bernoulli trial is repeated n times and each trial is independent. Okay, so repeated n times and the probability of success p is a constant. So probability distribution for x is a binomial denoted. Okay, we write down as we call the distribution as an x binomially distributed with n number of trials and p the probability of success. It's rated as x is binomially distributed where n is the number of trials and p is the probability of success. Okay, it's how we rate it, and it's given by the formula of what we call NCX. So NCX is what we call n factorial divided by n minus x factorial x factorial. Okay, P the number of trial of success multiplied with an x, and Q. So P plus Q equal to 1. P the probability of success and Q the probability of failure. So P plus Q equal to 1, then Q equal to 1 minus P. Okay, X is a number of trial, 0 until n. Okay, so n number of trials, P probability of success, and Q is a probability of failure, and Q equal to 1 minus P. Example number 1. A fair coin is tossed 3 times. So find the probability of getting no head, exactly 2 heads. Okay, before that, let's declare something. Let's say if x represent, call the number of heads obtained, then now look at this one here, x binomially distributed with n number of trials. It tossed 3 times, so then the number of trial of n here is 3, and when we toss a coin, there are 2 only results, whether head or tail. So everything we call each of these we call two results, head or tail, come up with us equal probabilities. Where head, getting head we call as a P, which is 0.5 or 1 over 2, and also tail as a failure is also result of 0.5 or 1 over 2. Okay, so we write down as a P here 0.5. So then, okay, probability of x equal to an x equal to the number of trial and cx, then p to the power of x and q. Q is 1 minus p and minus x. Okay, please refer to the previous notes then. Okay, so here p, x, probability of x, and cx, p power of x, and q. Q is 1 over 1 minus p, power of m minus x. Okay, so now let's recall p is 0.5 and q is 0.5. So no heads. No heads means that the probability of x equal to 0. Okay, probability of x equal to 0. So n of number of trial is 3. 3C0, okay, and P is 0.5 to the power of X. X, in this case, which meaning is no head. Recall, when we toss the coins, we don't get the result of head facing our eyes then. So it is 0 and 0.5, and then n minus x, 3 minus 0 equal to 3. Okay, so for this one, you may use your calculator. Okay, you may use your calculator to find the answer of this. Okay, 3C0. Okay. Multiplied with 0.5 to the power of 0 and 0.5 to the power of 3. Okay. Okay. As you see on the screen here now. Okay. The one here. Okay. Equal to 1 over 8. Okay, equal to 1 over 8 or 0.125. Okay. For the first time, we use the calculator, or we call the formula calculation here to get the answers. After this, we will refer to this statistical table, which I think that all of you have one copy each for each of you. So we will refer to this after this. Okay, now getting no head. So getting exactly 2 head, probability of x equal to 2. Okay, so then it is 3C2 multiplied with P 0.5 to the power of 2 and 0.5 to the power of 3 minus 2 equal to 1. Okay, again, 3C2 multiplied with 0.5 to the power of 2 and 0.5 to the power of 1. There you go. Okay. I get it as 3 over 8. Okay, from here. Okay, so you can see here now the screen. Okay, it is 3/8. Okay, 3/8 or 3 divided by 8, 0.375. Okay. Example 2. Okay. For example number 1, we use the calculation first, and after this we look into how to use the this statistical book. Okay. And then in the box, 20% of the bulbs are damaged. If a random sample of 10 bulbs is taken, find the probability that exactly 3 bulbs are damaged, all bulbs are good. Okay, not more, 3 bulbs damaged, at least 1 bulb. Okay. So class, from this, even though there are two, we call for binomial, there are 2 results, is whether pass, we call, or failure. Okay. And this one we call label as a P, and this is Q. But doesn't mean that in this case, pass means that the bulbs are functioning. Okay, the bulbs are in a good condition. In this case, we referring to the top, we call the subject here. 20% of bulbs are damaged. Okay, so we write down X is binomially distributed with n number of trials. Okay, 10 is a number of trials, 10 bulb is taken, but 10 not 80%. Okay, if we refer to the pass is based on the bulbs that are functioning in good condition, we put this as a P. But in this case, we are focusing on the percentage of the bulbs are damaged. So the damage 20% here as the P. Okay, again, not all that we call on condition, not all condition that when we talk about the P, the pass, or we call, and Q is failure, the pass meaning the things or the object is in good condition. But then in this question, example 2 here, we are talking about the bulbs are damaged, which is 20%. So this, well, the bulbs are damaged, which is 20% here, considering as the pass, okay, the label of P, and the bulbs which is in good condition as a failure. So please understood the question carefully. Okay, so in this case it's not pass, meaning that it's not for all condition that the things are in good condition. Okay, so this thing P is based on the topic here, 20% of bulbs are damaged. Okay. So now it is X binomially distributed. Okay, so the number of trials is 10 bulbs and 0.2. The bulb is damaged as a success. We call topic here 0.2. So P equal to 0.2, then Q equal to 1 minus 0.2, which is equal to 0.8. Okay. Now the first question then. Exactly 3 bulbs are damaged. So A probability of X equal to 3, which is 10C3 multiplied with 10, 0.2, sorry. Okay, be 0.2 to the power of 3, and 0.8 to the power of 7. Okay, again, for this one here now, 10C3 0.2 to the power of 3 and 0.8 to the power of 7. Okay, as you see screen here now. Okay, so the first one is 10C3 and okay, 0.2 power of 3 times 0.8 to the power of 7 equal to 0.2013. Okay, it is 0.2013. Okay, question B. All bulbs are goods. So when all bulbs are goods means that this is P, but this one considered that as bulb is damaged. Okay, so look at the question here. All bulbs are goods, meaning the damage equal to 0. Okay, so then we come up with probability of X equal to 0, then 10C0, 0.2 to the power of 0, 0.8 to the power of 10. Okay, 10C0, 0.2 power of 10, 0.8 power of 10. So use your calculator again. Use your calculator, which I think I show you a few times then. It is 0.1074. Okay. Next, not more 3 bulbs. Not more than 3 bulbs are damaged. So, how you define this? Not more than 3. Not more than 3. Meaning, X is exactly equal to 3. Not more than 3. Okay. It is X less than or equal to 3. Okay, not more than 3. So 3 is the limit. So either X equal to 0, X equal to 1, X equal to 2, and X equal to 3. So then, we are going to list down all this. Probability of X less than or equal to 3, which is probability of X equal to 0, plus probability of X equal to 1, plus probability of X equal to 2, plus probability of X equal to 3. Okay, so we list down all one by one. 10C0, 0.2 power of 0, 0.8 to the power of 10. Okay, this is for X equal to 0. For X equal to 1, for X equal to 1, it is 10C1, 0.2 to the power of 1 times 0.8 to the power of 9, plus with, for X equal to 2, 10C2, 0.2 to the power of 2, 0.8 to the power of 8. 10 minus 2 equal to an 8, plus with 10C3, 0.2 to the power of 3 and 0.8 to the power of 7. Okay. So now, we're going to list down one by one. Okay, find out the answers for this, this, and this, and finalize. It will give you 0.8791. Okay, which I think that because I have shown you a few times, recall how to find this using your calculator. So the rest of it you find it by yourself. Okay, and then at least one bulb. At least one bulb. So then D equal to the probability of X greater than or equal to 1. Okay. So class, for binomial, it is considered as a discrete, meaning the sign of greater than or equal and greater than are two different meaning. Okay. So for this one here, meaning from probability of X equal to 1 plus probability of X equal to 2 until probability of X equal to 10. Are we going to list down all this one by one from probability of X equal to 1 until 10? You may do so if you want to, but then let's make our life easier. It is 1 minus probability of X equal to 0. Okay. For this one here, which is 1 minus probability of X less than 1. Okay. Greater than, so including 1 here, so which is 1 minus probability of X less than 1. So less than 1, 0. So 1 minus this one here, 1 minus probability of X equal to 0. We get it from here. Okay, 0.1074 equal to 0.8926. 0.8926. Okay. Mean and variance of binomial. If X is distributed binomially with n number of trial and p number of success, then mean is n multiplied with p and variance equal to n, the number of trial multiplied with probability of success multiplied with probability of failure. Okay. So fair dice is rolled 300 times. Fair dice here. Okay. A fair dice, I do believe that all of you have seen dice before with 6 surfaces. Okay, 6 faces here, and every single face there's a value 1 dot, 2 dots, 5 dots, and so on. Okay, when we play a game, then we use the dice. So a fair dice is rolled 300 times. So this is the number of trial. Let X represent the number of times the number 6 is observed. Find the mean and standard deviation. Okay. Okay. So class, when we throw a dice, we will get a result. It's either 1, 2, 3, 4, 5, or 6. Okay. Meaning there are 6 results here. So every single result is what we call the probability is 1 over 6, 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 1 over 6. So let X represents the number of times the number 6 is observed. So when we throw the dice, so we look at we call on the top of the surface of the dice is we call give us number 6. So find the mean and standard deviation. So then X is binomially distributed with n trial, which is 300 times, and number 6 is observed. The probability is 1 over 6. There you go. Okay, now find the mean and standard deviation. So then mean or EX, or might be we write down with a symbol of mu here. Okay, equal to n multiplied with p, which is 300 multiplied with 1 over 6 equal to 50. Okay, the symbol of EX or mu here. So then variance equal to n multiplied with p and q. So 300 multiplied with p, 1 over 6, q, 1, q u equal to 1 minus 1 over 6 equal to 5 over 6. So then multiply with 5 over 6 equal to, okay, it is 41.67. And standard deviation? Standard deviation, which we call represented by the symbol of lambda here, it is square root of variance. Square root of variance, which is square root of 41.67 equal to 6.45. That's it. So binomial probability tables, to find the probability for value of p from 0.001 to 0.5. Okay, class, please refer to these books. Okay, so you can see, you can refer to these notes. The first page of this is all the stories about the binomial. Okay, and then the value that we get from this table, okay, the value that we get from this table is based on the probability of x greater than or equal. Okay, it is a summation of, and we call this formula from x equal to r until x equal to n. So every time you refer to the answers in this table, is all based on the value of probability of x greater than or equal. Okay. X is larger and equals to r. Okay. Example 4. Let x random be such that, okay, so this is we call the thing that we're going to focus on. X binomial distributed is n number of trials 0.5 and number of probability of success is 0.3. By using the binomial table, find, okay, class. This one we may straightly refer that we call get the answers from that table. But what about this? Okay, the result from this table, from this book, statistical table here, is based on the probability of x greater than or equal. So for this one here now, because the binomial is a discrete case. For discrete, meaning for x greater than 3, so we come up with x greater than or equal to 4. One after that. Okay. And this one here, okay. Let's say I almost recall sometime we can always use this rod. We call this for this to show the students. Okay, with a 0, 1, 2, 3, 4, 5, and so on. Okay, for x less than or equal to 3, equal to meaning is including 3, so it is from x equal to 0, x equal to 1, x equal to 2, and x equal to 3. The total of the probability are equal to 1. Please remember what we have learned last time in random variable. The summation of all the probabilities equal to 1. Okay, so for this one here now, because we wanted it from 0 until 3, so it is 1 minus probability of x greater than or equal to 4. Okay, and what about this one here now? X less than 3. Zero, 1, 2, 3, 4, 5, and so on. Okay, probability of x less than 3. Does it include 3? No. Okay, so before we call the figure that before 3, that include before, we call before 3, which is 2. So then it is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So this one here come up with 1 minus probability of x. Because it does not include with 3, it's only 0, 1, 2. So we minus 1 minus probability of x starting from 3 here. Okay, x greater than or equal to 3. And what about this one here now? Okay, zero, 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so we want the probability of x equal to 3. Just imagine that it is probability of x. Okay, probability of x equal to 3 minus probability of x starting equal to 4. So probability of x greater than or equal to 3 minus probability of x greater than or equal to 4, then we get the probability of x equal to 3. So in this case, it is probability of x greater than or equal to 3 minus probability of x greater than or equal to 4. So class, this all the rough picture of what we call to find the solution of this question, okay, using the statistical table. And let's solve it one by one. Okay, according to we call the notes, we refer to the latest books here. It says that turn to page 5 from statistical table. Page 5. Okay, page 5. And then what is the first question then? Probability of x greater than or equal to 3. Okay, probability of x greater than or equal to 3. So look at this one here now. Just now the question was that x binomially distributed with number of trials which is 5, I think so. 5 and 0.3. Okay, number of trials is 5 and p equal to 0.3. So look at this one here now. R, the number of trials of n of R here, n, which is R, referring to we call, okay, no, the n number of trials, we referring to this n equal to 5. Okay, so this R is referring to this number 3. So R equal to 3, greater than or equal to 3, and probability of success P equal to 0.3. So, okay, now we find where do they intersect or meet each other here from 3 and 0.3. Then we get 0.1631 equal to 0.1631. Okay, find the probability of value of p greater than 0.5. Okay, the next question, B, just now the probability of x greater than 3. Okay, for this one, we refer to the value of R, which is after the 3 because it does not include 3 but is greater than. So it is probability of x greater than or equal to 4. Okay, so it is greater than 3 but does not include 3. So we look into the value after that, which is 4. So x greater than or equal to 4. So, okay, 0.3, where n equal to n equal to 5, 0.3, and then r equal to 4. R equal to 4, 0.0368. Okay, you get it? Okay, so wait a minute. Okay, where n equal to 5 first, n equal to 5, okay then, and probability of success is 0.3, okay, and r equal to 4, where r equal to 4, okay, so then it intersects at a value of 0.0308. Okay, try to find it by yourself then here. Okay, now the next question, see probability of x less than or equal to 3. Okay, so I did show to all of you before this one here. Okay, x less than or equal to 3 is all here. So you may refer to this when I discuss all this question here. Okay, it is 1 minus probability of x greater than or equal to 4, and is 1 minus 0.0368 equal to 0308, sorry here, equal to 0.9692. D, probability of x less than 3. Okay, it is 1 minus probability of x greater than or equal to 3. It is 1 minus probability of x equal to 3 just now, which is 1 minus, okay, 0.1631. 0.1631, which is equal to 0.8369. Okay, and E, probability of x equal to 3. It is probability of x greater than or equal to 3 minus probability of x greater than or equal to 4. It is 0.1631 minus 0.0308 equal to 0.1323. There you go. To find probability for value of p greater than 0.5. Okay. Okay, for this case, where x with binomially distributed with n and p. Okay, now, when p, the value of p itself is greater than 0.5. So there will be some changes here. The need to make some adjustment. Okay, with all we call the notes you can see here now, and let's see how we're going to use that. Okay, let x be a random variable such that x binomially distributed with n equal number of trial is 10 and p is 0.8, where 0.8, sorry, where 0.8 is greater than 0.5. Okay, using the binomial table, find the probability of this. Okay, so then for this one here, okay, the first one, A, probability of x greater than or equal to 4 is also equal to probability of y. So with the x, we change with the term of y here, greater than or equal to change to less than or equal. So 10 minus 4 equal to 6. Then the number of trial minus 4 when x greater than or equal to 4 here, then come out with probability of y less than or equal to 6. Okay, so it is again is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so y less than or equal to 6, including 6. Okay, including 6, so means that we are going to minus 7, we call x probability of x equal to 7 and the rest of it. Okay, it is 1 minus probability of y greater than or equal to 7. Okay, it is 1 minus, okay class, I forgot something here. Okay, for this term, from x binomially distributed for 10 and 0.8, then we change it to the term of y binomially distributed, where it is the number of trial is 10 and the number of success here is 0.2. So this is our reference now. Okay, so this is our reference now. Okay, so then refer to the statistical table where n number of trials equal to 10. Okay, and the number of success, probability of success is 0.2. Okay, turn to page 6. Okay, turn to page 6. Okay, from here, the number of trial is 10. Okay, as you see here now, number of trial is 10. And then, probability of success is 0.2. Here. Number of trial is 10 and probability of success is 0.2. Okay, and then it is greater than 7. Greater than 7. Okay, it is here 7. Okay, so then where do you intersect with each other here? 0.2 with 7 here, it is 0.0009. With here. Okay, so it is 0.0009 then equal to 0.9991. Okay, probability of x greater than 4. Okay, x greater than 4. So does not include 4, meaning we look into the value after 4, which is 5. So probability of x greater than or equal to 5. So again, using the y binomially distributed with number of trials is 10 and number of probability of success is 0.2. Refer to the statistical table again, the books, and wait. For this one, x, sorry, it is an x here. Okay. Okay, sorry. Okay. So this x referring to the x binomially distributed with 10 and 0.8. So because again it is greater than 0.5, we make this one as a probability of y less than or equal to 5. So then this one refer to the y binomially distributed with number of trials 10 and number of success is 0.2. So this is the one that we refer to the statistical table for y greater less than or equal to 5. But then this table, this book, give us the, we call the reading for x greater than or equal to r. So for this one here, we come up with 1 minus property of y greater than or equal to 6. Okay, so meaning here, it is 1 minus, so find out this in the box, it gives you 0.0064 and is equal to 0.9936. And then for property of x less than 4. Okay, again we refer to this and we turn up into, okay, x less than 4. Less than 4 meaning it is property of x less than or equal to 3 because it does not include 4. So before 4 it is 3. So including 3, 2, 1 and 0. Okay, turn it into the y binary distributed property of y greater than or equal to 10 minus 3 equal to 7. Okay, and this one here now, property of y greater than or equal to 7. Okay, again, with the number of trials is 10. Number of trials is 10, still in page 6. Okay, in page 6. Number of trials is 10 and 0.2 and y is greater than or equal to 7. I think we have found it earlier just now, which is 0.0009. Okay, this one. So example 6. For random variable x with a binomial distribution of 10 and 0.45, find a when a is greater than this one here. Okay, class. For this one, we are going to find the value of this. Okay, we are going to find the value of all this 1, 2, 3 inside the box of this table. Okay, inside the box of this table, and we try to find what is the value of a here. Okay, so then for this one, the number of trial is 10, and recall the p of success here is 0.45. Okay, so the number of trials here is 10. Then to page 6, and then recall probability of success is 0.45. Okay, so greater than a, 0.4956, 0.49. Okay, where n equal to 10, p is 0.45. So we are going to refer to the line for this line and 0.4596. Okay, 0.4596, 4956 here. Okay, then the n equal to, the r equal to 5. Okay, for this one here, probability of x greater than equal to 5 equal to 0.4956. So then the value of a here is equal to 5. Okay. Then next, x less than or equal to a. So for this one here, property of x less than a, it is property of x, okay, less than some one value of a, the less than 3, for example, property of x less than 3, it is less than 3, which is x equal to 0, 1, and 2. Okay, so it is 1 minus property of x greater than or equal to 3. Okay, so what about this one here now? X less than a. It is 1 minus property of x greater than or equal to a, equal to 0.89801, 0.89801. Sorry. Okay, for this one here now, 1 minus property of x greater than equal to a equal to 0.809, 0.89801. So then property of x greater than or equal to a equal to 1 bring here become negative. So 0.89801 minus 1 multiplied with negative left and right, and property of x greater than equal to a, it is 1 minus 0.89801. And this gives you 0.1020. Okay, so 1020, again, when b number of trials is equal to 10 and p is 0.45. 0.1020. Okay, 0.1020 refer to this one here where r equal to 7. Okay, then for this one here, a equal to 7. Property of x greater than or equal to 7. So find the value of 7, you find that it is value is 0.1020, the probability. Okay, so you try this by yourself here. Okay, so the binomial distribution is given by here, and for special case, p is greater than 0.5. So I hope all of you understood the process of changing it from the x to y binomial distributed here to find get the answer. Okay, so let's exercise. That's all for today, which I think that we'll meet again. Okay, we'll meet again in the next we call series of videos for this topic 10, for another topic 10 here. That's all. Assalamualaikum warahmatullahi wabarakatuh.